Schmit orthogonalization procedure or GSO procedure. Here we are given 4 signals and we want to find the orthonormal basis function of these 4 signals. Okay, so there are total 4 signals. So if 4 signals are given, the number of orthonormal basis function will be always less than or equal to 4. So maximum basis function will be 4. Maximum number of orthonormal basis function will be 4. So the number of orthonormal basis function will be always less than or equal to the number of given signals. So we go to the step 1. So step 1, we define the first basis function phi1. Phi1 is given as first signal divided by root of energy of the first signal. So the first basis function is consider the first signal divided by root of energy of the first signal is your first basis function. So when you do the problem, the one thing that you need to keep in mind is this phi1, this is a basis function, that is a waveform, and the given S1 of t, S2 of t, S3, S4, all these are waveform. But the energy, when you calculate the energy, what you get is just a scalar value. So that you need to keep in mind. These two are waveform and this is a scalar. So a waveform, you need S1 of t is a given signal or given waveform that you need to divide it by a root of energy, that is a scalar quantity. So first you find this energy. So in order to find the energy of the any signal, the equation is this, that is you have to integrate the signal over the period and take the square, S1 square t dt. So first to do the integration, first you consider the symbol S1 of t and find out what is the limit. That is limit of this signal is from 0 to t by 3 and its value is 1. So this limit, integration limit changes from 0 to t by 3 and its value is 1. So x1 square dt, that is 1 square dt. So you will get the answer. So what you obtained is just a scalar. Energy is a scalar. So you have to divide the first signal by the root of the energy. So a given signal divided by a scalar quantity means that is you have to divide this S1 of t throughout by this scalar quantity. Okay. So divided by root t by 3 means you need to multiply this signal by root root 3 by t. You have to divide it by root t by 3. So you need to multiply it by root 3 by t. So this is just a scalar value. You need to multiply it with, say, waveform means you have to multiply throughout this waveform. So when you multiply throughout, what you get is your waveform that you obtain will be phi1 of t, and phi1 of t is having the value root 3 by t from 0 to t by 3. That is throughout the waveform of S1t you are multiplying this. So here this is your first basis function. Now the step 2, this is actually we need to do. We define an intermediate function g2. That g2 is given as second signal minus component of the second signal along the remaining basis function. That is the equation. Second, you define intermediate function, that is J2 is second signal minus component of the second signal along the remaining basis function. Here you have only one basis function. So second signal minus component along phi1. So that coefficient is S21, that is component of the second signal along first basis function. Here also you should have a clear idea. G2 of t is a waveform, S2 of t is a given signal or given waveform, and phi1 of t is a first basis function, that is again a waveform. But here this quantity S21 is actually the coefficient, that is again a scalar quantity, that is a coefficient value. So first you need to find this, and all others are waveform, so you can directly draw the waveform and find out the result. So before that you need to find out the coefficient S21. So how to find out the coefficient S21? S21 is a component of the second signal along the first basis function. So S21 is given by S2 into phi1, second signal along the first basis function into this 1 to 2. Now see, this is a waveform, this is a waveform, that is these two are signals. Okay, so you need to multiply two signals. So how will you multiply two signals? Draw the signals and multiply each point by point. Okay, so this is S2T and this is 5T. Multiply these signal point by point. You see, this is 0 to 2T by 3, this is 0 to T by 3. So T by 3 will be a point over here and 2T by 3 will be a point after T by 3. Okay, now multiply each point by point, these two waveforms, then only you need to do the integration. So from 0 to 2 by 3 it is 1, so 0 to T by 3 it is root 3 by t. So root 3 by t into 1 you will get root 3 by t from 0 to T by 3. Now see, from T by 3 to 2T by 3 it is 1. From T by T 2 by 3 this one is 0. So 1 into 0 you will get the value 0 after T by 3. So this is your multiplied waveform. So first multiply the waveform, then do the integration. So the limit will change based on this waveform. Now the waveform is having the value root 3 by t only from 0 to T by 3. So the limit will change from 0 to T by 3 and this value is root of 3 by t. Then do the integration. You will get the answer. Okay. Now this is the coefficient. You can substitute in your equation for your intermediate waveform G2 of t. Now take G2 of t equal to S2t, draw S2t, this is a waveform, draw it, minus S21. S21 is what you have calculated. S21 is root t by 3. S21 is root t by 3. So that you have obtained root t by 3 into 5 and t. 5 and t is that you have already found. So you know that is again a waveform. What is 5 and t? 5 and t is having the value root 3 by t from 0 to t by 3. This is here 5 and t. So this 5 and t you need to multiply it with S21. So S21 is root t by 3. So root t by 3 multiplied by root 3 by t means you have to multiply the throughout the waveform by that coefficient or scalar. So what happens is 3 by t and t by 3 will cancel out. You will get the value 1 from 0 to t by 3. So that is S21 into 5 and t. So S21 into 5 and t, his value will become 1 from 0 to t by 3. Now you have two waveforms. You can easily subtract this waveform. So how to subtract the waveform is a direct subtract each point by point. So you see, again similar to earlier, you see this is 2t by 3. So t by 3 will be a point over here and 2t by 3 will be a point over here. 0 to t by 3's value is 1. So 1 minus 1 you will get 0. So 0 to t by 3 value is 0. Then t by 3 to 2t by 3, here the value is 1 and here the value is 0. So 1 minus 0. So you will get the value as 1. So this is a waveform. It is having the value 1 only from 2t by 3 to 2t by 3. Now you get the intermediate waveform G2. Now the basis function is given as phi2 equal to G2 divided by root of energy of G2. So similarly, you know, this is energy. So this is again a scalar value. So a waveform, you have to divide it by a scalar value, means that waveform throughout you have to divide it by that particular scalar value. Okay, so first we find the energy. Energy is integral 0 to t G2 square t dt. Okay, so the limit will change according to this waveform. So G2t is t by 3 to t by 3 1, is it? So the limit will become t by 3 to 2t by 3, its value is 1. So 1 square dt. Energy is, you have to take the square. Okay, 1 square dt. Do the integration, you will get the value t by 3. Okay, now G2 of t divided by root of t by 3, is it? So this, you remember, this is a scalar quantity. You have to waveform divided by a scalar quantity means this waveform throughout you have to divide it by this. Okay, so divided by root of t by 3 means we have to multiply it by root of 3 by t. So throughout the waveform you have to multiply it by the scalar. So what will be a phi 2 of t? Phi 2 of t will be root of 3 by t from t by 3 to 2 by 3. Because here the value is 0, here the value is 0. You have to multiply it throughout by this scalar quantity. So this will be a phi 2 of t. Now the remaining waveform calculation is the same. To find out the third basis function, you again define another intermediate function G3, that is S3 minus component of your third signal along all the remaining basis functions. So phi 1 and phi 2. So its coefficient is S3 along phi 1, S3 along the second basis function phi 2. Similarly, you find S31, S32. So remember, in my S31 is a scalar quantity, S32 is again a scalar quantity. First you find this value and multiply throughout the waveform phi 1 and phi 2. Then plot this S3. Then S31 into phi 1 is the second waveform, S32 into phi 2 is the another waveform. Then do the subtraction. When you get G3, phi 3 is G3 divided by root of energy of G3. So similarly, we proceed till you get any of the GAT value equal to 0. When you get any of the GAT equal to 0, you can stop there. Keep in mind, not coefficient. The GAT value should become 0. Then only you can stop. Okay. So see here you have G3 defined by the equation. First you need to find S31, S32. So S31 you know the formula, X3t into 5t. Find out the value. So first these two are waveform, multiply this waveform, then do the integration. So when you multiply this waveform, multiply it point by point. So 0 into 1, 0 into root 3 by t, it becomes 0. Then t by 3 to t it is 1. Here it is 0. So this value will be 0. So S31 coefficient S31 will become 0. Then find out S32. S32 is S3 into 5 to multiply this waveform point by point. So 0, 0, t by 3 to 2t by 3. Here you have root t by t. So the value is root 3 by t. Then from 2t by 3 to 2 by 3 is a point over here to 2t by 3. After here the value is 0. Here you have 1. So its value will be 0. Multiply and do the integration. You will get S32. Then find out G3. G3 is S3t. Plot the waveform S3t. S31 is 0. So this term completely becomes 0. Then S32 you got the values root t by 3. Phi 2 you have already have the phi 2. Multiply it throughout the scalar. So this amplitude will become 1. Then subtract this waveform point by point. So 0 minus 0 you will get 0. T by 3 to 2 t by 3 again it is 1 minus 1. Again you get 0. 2 by 3 it is 1. Here it is 0. 1 minus 0 you will get 1. So you have G3. Then find out the energy of G3. Energy of G3 is G3 square integral G3 square dt. So here the limit is 2t by 3 to t 1 square dt. Find out the value. Then divide by root of energy of G3. Okay, so divided by a scalar means divide throughout the waveform by this scalar. You will get the phi 3. Similarly, continue for phi 4, G4 since you have 4 signals. G4 again use the same expression. Find S41, S42, S43. Then S41. Then you have S42. Then you have S43. Then substitute in your equation for G4. You will get the value of G4 equal to 0. That means the fourth basis function is 0. That is, you have only 3 basis function, phi 1, phi 2 and phi 3. Okay, thank you.